The challenge here is the following. So this forward-looking model cannot really match this empirical regularity, which is, if you look at this at macro aggregate variable response to identify the shocks, typically they have kind of like a hammer-shaped response or sluggish response. And this textbook version forward-looking model cannot deliver this hammer-shaped response. And the second kind of difficulty is this forward-looking model sometimes respond too strongly to news about this distant future fundamental. One example is a forward-looking puzzle. And to address this difficulty, in the standard DSGE literature, people do is they can add different frictions or behavior modification to the underlying model, such as, say, in New Keynesian curve, they can assume that some firms are backward-looking or inflation is a back indexation. And for the consumption, they can assume that there's a habit formation. And for investment, they can assume there are certain kind of adjustment costs. All of these elements trying to give you this sluggish response to the underlying shocks. But the problem is these frictions or modification required at the macro level is not consistent with the micro level evidence. For example, say for a habit, for example, the kind of like habit formation in the macro literature is something like 0.5, 0.6, but if you look at the micro level evidence, it's almost 0. If you think about, say, investment adjustment costs, there's no micro foundation for that, and so on and so forth. So what we're going to do in this paper is the following. We're going to provide a simple solution to both of these two issues. And this solution is going to be consistent with the rational expectation equilibrium, and also it's going to be consistent with evidence on expectations. And this is what we do. So we're going to start with this textbook version forward-looking model. We're going to add several elements on top of it. We're going to add the following. First, we're going to add incomplete information in the sense that people are going to have, they don't know the fundamental perfectly. Second is we're going to add high order uncertainty in the sense that they don't necessarily know what other people's response or awareness is. And the third is we're going to have Bayesian learning. With these elements, we're going to find that at the end of the day, the aggregate outcome is going to be observational equivalent. Yeah, thanks. Going to be observational equivalent to this representative agent model, but it's a hybrid in the sense that there are going to be two behavior modifications compared with our textbook version. The first modification is there are going to be a backward-looking component, at-1, and we call this part like anchoring because it's linked to the past. The second modification is going to be this omega f, which is less than 1. This brings additional discounting of future, and we call it myopia. So these three elements can deliver these two behavioral modification, and also this behavioral modification going to be stronger. The stronger the general equivalent effect is, or stronger the strategic complementarity is, and they're going to be more prevalent at the macro level than at the micro level. Okay, this is our theory. So we bring this theory to a couple of applications. The main one is the Keynesian curve application. What we do is when we build on this new Keynesian curve and add these elements, we can rationalize evidence on this hybrid New Keynesian curve estimated by Galli and Gertler. This hybrid model they provide there, we have like this, our information story going to provide those estimates. And also simultaneously, we're going to match the evidence on inflation expectations in the sense that we're going to jointly not only match the time series on real marginal cost, inflation, we're also going to match the forecast about inflation and so on and so forth. And we're going to quantify the role of information friction. And we do also other applications in the paper, but in the talk, we're going to focus on this one. Okay. I'm going to skip the literature, but later on, I will bring this back when it's relevant. So this is our framework. Think about like in this economy, there is a continuum of infinitely lived agents with this OLA-like best response. So think about individual I. Individual I's action, AI at pure T, AIT, depends on the following things. First, it depends on the fundamental CT. And we're going to assume that this fundamental can be persistent over time, and particularly for this AI1 process. It also depends on their own future action, AIT plus 1. And crucially, also depends on what other agents' choice in the next period, AT plus 1. This is going to be the aggregate action in this economy in the next period. And here, the important parameters are the following. So this gamma capture what we call this GE effects, or degree of strategic complementarity. And the beta controls individual discounting or partial equilibrium effects. And crucially here, agents are forward-looking, so this is effectively a dynamic beauty contest model. So in the literature, you see more commonly what happens is everything happens simultaneously in the same period, and here, agents are forward-looking, so this is going to be a dynamic beauty contest.
So we should think this is a linearized version of a set of models?
Yeah, that's the right way to think about it. You think about like any macro model, after you linearize or like linearize, going to have something like this. Just give one example to concrete this idea is, suppose think about your Keynesian curve. What happens is for each individual firm's pricing decision, what they want to do if they have the chance to reset their price, they're going to do is they're going to set their price as some weighting average of current and the future nominal marginal cost. And here, think about this CT, in this case, going to be the real marginal cost, and this is aggregate price. And theta is the capital probability. If you aggregate this individual decision, you get this in equilibrium, the inflation rate can depend on the entire path of current and future real marginal cost, and also entire path of current and future inflation rate. And this one can be rationalized or derived from this dynamic beauty contest model as we showed earlier. And in this case, you can see what is the beta and the gamma exactly. It's going to depend on the cover pricing, depend on discount rate, and so on and so forth. It's just a concrete example. All this macro model can somehow cast into this framework. Okay? So here, notice that I use notation EIT means that the potentially different agent can have different information. Let me start with the simple one in the case that all the agents share the same information and actually complete information. They know exactly what his fundamental is. This is...
yeah. In all these settings, in all the models that you have in mind, they will boil down to a parameter, beta and gamma.
Yeah.
There wouldn't be models in which beta is endogenous or gamma is endogenous.
So here we're going to assume that you know the environment, you know the primitive stuff, and you do the linearization, and the beta and gamma are the function of the parameter which is fixed. Okay. So think about this special case in which all the agents share the same information, which is complete information. In that case, everybody going to be the same. They like each other. In that case, AIT and AT plus 1 and AT plus 1 going to be the same because everybody is the same. It's identical representative agent. In that case, we reduce to this standard representative agent model. So this is a beta plus gamma, we call it delta. This is what is relevant because AIT plus 1, AT plus 1 are going to be the same. And everybody know what his fundamental is. And this is the standard macro model. Next period fundamental, the forecast is going to be just rho times today's fundamental, and the day after tomorrow is going to be rho square, and so on and so forth. So at the end of the day, this geometric sum is going to be proportional to the current fundamental. So what you get is the solution to this complete information model will be AT star. The star means it's complete information going to be proportional to the current fundamental. Now, if you think about the impulse response to this model, what happens is this CT follow AI1 process. Then if you give a shock, the aggregate action AT star going to be monotonic decline over time. You don't have this sluggish or hump-shape response. And this is the failure of the standard textbook version model. So now let's move to the case when you don't have complete information. So the question is, why do we want incomplete information in the first place? There are two reasons. The first one is just naturally we don't have complete information. We don't know the fundamental perfectly. So it's natural to assume that we don't have complete information. But more importantly, the complete information assumption kills all the possibility that agents have kind of doubts about others' response and others' awareness about underlying fundamental. Not only like they know the fundamental perfectly, they also know others know it perfectly. So this kills all the coordination failures. So what we're going to do is we're going to assume that agents, they do not know the fundamental perfectly. They're going to receive a sequence of signals. And particularly, each period, what they observe is the fundamental plus idiosyncratic shock, UIT. It's like noise. And this UIT follow normal distribution, and the standard deviation is a sigma. So suppose sigma equal to 0, you go back to the complete information case. And suppose sigma is positive, you don't see the things perfectly. And here, agents, they have first order uncertainty because they don't know what the fundamental perfectly. But also because everybody received their private information about the fundamental, there's also going to be high order uncertainty in the sense that people don't know what others believe about the fundamental necessarily. So this is important.
So the epsilon is also idiosyncratic, or is it common to the whole economy?
You mean, yeah, that is common because so notation-wise, there's no index I, means it's a common for everybody.
I know, but could it be that there are some fundamentals related to the individual?
Yes, it's possible. It's possible. So if we wait like 10 slides, I'm going to cover that case also. Okay. So once you have this income information, now it is different that everybody has different information, and AIT can be different from AT now. So you have to separate these two things now. And now if you do the forward iteration, what happens is agents are going to have different information set. So the law of expected iteration is going to fail. What happens is aggregate action will be determined by not only the belief about current and future fundamental, and also depends on the average belief about aggregate action in this case. If you compare with the complete information case, here the action depends only on the belief about the fundamental. And now the action also depends on the belief about others' action. So here you can see clearly beta and gamma play a separate role here. Beta controls the rate of discounting, but the gamma controls the strength of complementarity and how much you rely on others' action.
What are agents going to know about the other's information?
So this is the information structure. So I see my current this is my current signal. I see this common fundamental KCT with idiosyncratic noise. And I know other people are going to receive similar information. They're going to be, KCT is correlated, it's kind of like a common component in everybody's signal.
You know, with regard to the expectation of the others, there's an expectation you're going to measure with ratio of probabilities.
Sorry, say it again? You can always.
You can hit the agents with the ratio of probabilities. You can always rewrite the others' information with your own information and then do the law of expectation.
You can always write your others. Sorry, I don't get it. Let's say it one more time.
So, can you go on?
Yeah. Mm-hmm.
So 1E is with respect to I's information?
Yeah.
So why do you say that the law of information?
Because if you think about, say, you and me, we have different informations.
No, I'm not. So there's E of I.
Yeah.
And then what happens is what the AP has the AE,
Here.
the E of the other agent.
Maybe here gonna be helpful. Okay, maybe here. So what happens is if I think about, if I don't think about what others are trying to do, I'm trying to think about what is average belief about its KCT. So that's, in that sense, I'm trying to do EIT of average of ET. So that doesn't, because these two information sets are not the same, you cannot do the law of iterated expectation.
You can rewrite the expectation of the other in terms of your own measure, and then apply the law. Is it whole thing like Thompson or forecasting?
Yeah, yeah.
I would disagree. What he means about you cannot apply is that you cannot do it. There's something there that creates a difficulty that ends up making you represent it. Like, there's nothing can be learned. That you end up having a representation.
You can definitely like form others. You can form belief about others' belief and so on and so forth. That's no problem. I'm just saying like technically, a law of iterated expectation gonna fail in this context because people have heterogeneous information. And in Townsend's case, they're gonna have exactly the same representation as here.
Explaining it like that is a bit ambiguous because you say the law doesn't apply, but I say when you multiply AT, the aggregate AT by the ratio of their information to my information, then I apply it. So saying it like this is a bit ambiguous. That's why I wrote this. But you can go on.
Okay.
Sure, okay. I'm just trying to figure out exactly what is the departure from rationalizing.
Yeah, maybe let me try to use this case to go through one more time, see if it helps. So suppose I think about, say, okay, let me go back actually. So here, if I think about individual action, I want to think about what is others' action next period. So I know like in the next period, what's going to happen is everybody else in the next period is doing the same kind of law of motion. So in the next period, AT plus 1 going to be average belief of AT plus 1 and average AT plus 1 and average AT plus 2 and so on and so forth. So when I try to think about what is others' action going to be next period, I have to think about what is average belief about fundamental next period. So I'm going to have EIT of average E bar T there. So that is a second order hybrid belief because information set is not the same for myself and the average economy. I cannot collapse these two. That's what I meant.
What you're saying is that with my own information, I cannot figure out.
You cannot figure out exactly what others' belief is going to be, but you have your probability assessment of what others' belief is going to be.
It means that in order to apply the law of interpretation, I need more information.
Yeah, you need more information. You need, yeah.
Than the one I have right now.
You need to know exactly what is the aggregate shock is. Okay. Okay. So as I said, like if you iterate this forward one period, what happens is if you think about what is average belief about the next period action, you're necessarily involving this my average guess about the next period average guess about the fundamental in the next period, and this is the second order belief. And also you have to guess what is aggregate action in the next period. Okay. If you keep doing this, what happens is the aggregate action going to be a weighted average of all this forward higher order belief. It's going to be weighted average of average belief about the fundamental today, the second order higher belief about fundamental tomorrow, and the third order higher belief about fundamental 2 days ahead, and so on and so forth. Okay. Just to give you like a visual sense of how these things look like. So if we start with this complete information benchmark, what's going to happen is with the complete information, everybody shares the same information set. So there's a law of iterated expectation going to work. And all this forward header belief going to be the same as the first order belief. In this case, the forward header belief in H period is the same as the first order belief for the fundamental in H period. And this is equal to rho to the power of H KCT, so which is proportional to the current fundamental, just scaling down a little bit. Suppose I think about impulse response to a fundamental KCT. What happens is this solid blue line is the impulse response of fundamental itself. It follows L1 process, so it's going to going down gradually. Now if I think about in the complete information case, the forecast about the next period fundamental, you just row multiply this, you shift down a little bit, but it had the same kind of shape overall. And for the H period ahead, you just keep shift down this. And this is the case with complete information. All these objects look like this over time. Now let's go to the case with incomplete information. In this case, things are going to be different. So let's start with the first order belief first. So this is the fundamental itself, and this is the first order belief, the average first order belief. So it has this hump shape. This is because initially people not quite sure what this is because of noise or because of true fundamental. So initially, naturally, they're going to say, okay, maybe part is because of fundamental, part because.
That's because fundamental is persistent, but the noise is not.
So for the first period, this is not captured this full response. That is independent of whether it's persistent or not. Once you have a noise, even it's ID, you can under response to it.
But you're saying that the reason why it's unshaped.
Hump shape is because persistent. Yes.
As sincere repetition of deviation from the mean, you tend to limit it more.
Yeah, it's like as time goes, you see like a sequence of passive realization. You say, okay, this cannot be pure noise. It has to be fundamental change. In this case, you have this kind of like hump shape response. So you can see like now, this is the first order belief gonna be. This is noise. Yeah. Yeah. A question?
Following up on Victor's
Yeah.
question, if the noise would be persistent,
Uh-huh.
would you still have the hump shape?
Yes, yes. So you're saying like suppose that this UIT, the idiosyncratic noise is persistent. So what happens is the overall the shape is going to be similar. What's going to change is the exact dynamic gonna be slightly different because you have additional persistence when you write down the common filter problem. But the general property of initially under response and this gradual catch up, those going to be robust. Actually, in the paper, we actually show that you can use not only AR1 or with a persistent noise, like any stationary process going to have this property. This is a kind of like a cute example to illustrate the idea. Okay, so this is the first order belief. If you think about, say, the second order belief, which is to think about average belief about fundamental next period, in this case, it's going to be different from the first order belief, and particularly, it has a two property as you increase order of higher belief. One is, in general, is going to be shift down in the sense that it's a response less and less as you increase order of higher belief. The second property is, if you look at the peak of this, going to shift to the right. This is the sense that it becomes more and more persistent or more inertia going to inherit by this higher belief. So these are two properties. So at the end of the day, what happens is this aggregate action going to be the weighted average of all this high order belief. And the weight you assign on low order versus a high order belief is captured by this gamma, which controls the degree complementarity. If you have large gamma, it means that you have a high complementarity or high, stronger general equilibrium effects. You're going to assign a higher weight on those high order beliefs. If you have smaller gamma, you're going to assign a larger weight on the low order beliefs. So this determines the general dynamics of aggregate outcome. If you want to say literally spelling out all of this dynamic higher belief and summing that up and get the aggregate outcome, you can do that, but it's quite hard to do it in general. What we're going to do is we're going to bypass. Mm-hmm. Let me say it one more time. So this, yeah, this is like doing impulse response to the KCT shock. To the KCT, to the fundamental KCT. It's impulse response to KCT. To KCT, this one. So this one has a follow AR1 process. I'm going to shock this variable. So it follow AR1 process. This is impulse response of this object. Okay, so this blue one. This one here, the first dashed line, gonna be the economy-wide average forecast about this object, KCT. This is the first order belief. The next,
What agents think is
agents believe about,
what agents think about the impulse response.
it's an impulse response of agents' belief about fundamental. Oh, why does it keep moving?
For any age, for some age.
For the average agent. Yeah.
Agent, the average agent.
What the age takes the order of these.
Hmm?
Age, the letter H
Yeah.
takes the order of.
The order of the letter.
Each line is an age, right?
Each line is an age.
Ah,
Yeah.
each
Yeah.
line is
Yeah.
an age. Each line
Trying to
is
get
an
there,
age.
yeah.
Each line is a different.
Yes.
Yes.
So it's here is this H play a dual role in some sense. Okay, you got. Let's move on. So we're going to bypass the complexity of this higher belief, and we're going to solve this fixed point directly. And what happens is the aggregate outcome in this case with income information, going to look at the following. Remember that AT star is a solution under complete information, which is proportional to the fundamental itself. With income information, it does two things. So there's going to be a scalar var theta between 0 and the rho. And this var theta is going to control two things. First is this constant will be less than 1. Means that the initial response is going to be dampened. Because var theta is less than rho, this is less than 1. And the larger var theta is, this one going to be closer to 0. So more and more damping, the larger var theta is. And simultaneously, this var theta also control this additional persistence of aggregate outcome. So this is kind of like AR1 term, this L is a lagging operator. This tells you that the larger var theta is, you're going to have a more additional persistence of the aggregate outcome. And this var theta is a solution to this cubic function, which is dependent on the D parameter of the model, beta, rho, sigma, and gamma. This is going to be the solution look like. Okay, so there's one important property of this solution. Notice that this var theta, this one single number, controls the entire dynamics, and this var theta is going to be increasing in both the size of information friction and also.
So I understand that age is when you do the iteration age times. What is the age OB and the RE fixed point?
Okay. So
Put backward the relation between ATs and the higher order beliefs. That's
yeah, here is like aggregate action going to be dependent on all this higher belief. And I'm going to tell you, like, I'm not going to calculate each of these higher belief. I'm going to solve this original fixed point problem directly. I'm going to tell you what is AT, the process going to follow.
But we have the word rational expectations there.
Yeah, it's because this is a rational expectation model.
The agents have what information?
This is information. They see the noisy version of fundamental every period.
They're doing this form of guess and verify. But the this process. Yeah, this process. You're doing a guess and verify that has a linear problem. Then I'm going to argue that that's decomposed by
Yeah.
having this item by item, order of the linear order of the linear. But
That's the
that's a
solution.
guess and verify that
Yeah.
the solution has these forms.
The rational expectations when everybody sees their own signal
Yes,
only,
yeah.
and they know the joint distribution
You know,
of
yeah.
A and their
Yeah.
So rational
It's common prior.
with partial information.
Yeah, it's rational expectation with incomplete and dispersed information. This is the solution look like. I'm trying to say, like, you can see this in two ways. One way is
What's the name then? So rational expectations calculating with partial information.
yeah. I'm trying to say is like there's just two ways to see this. One is You can think about this as the infinite sum of all this hybrid belief, or you can think about this fixed point problem directly. Yeah.
You change the name of things because you compute it in a different way.
Yeah, this is a point in the sense that if you want to compute the equilibrium, you go to the fixed point directly. That's the easy way to go. But if you want to understand the property of this hybrid belief is going to be helpful in understanding the property of the problem.
There's lots of papers that get at this fixed point from another point of view, and they don't change the name of the
I didn't change the name. It's just fixed point. Yeah. Okay. So this is the equilibrium outcome for two different var theta, one a high var theta and a low var theta. So this blue line here is impulse response under perfect information, which is proportional to the fundamental. When you have a high var theta, what happens is initially you're going to have a larger dampening and you're going to have a larger persistence. When you have low var theta, you're going to have a smaller damping and less additional persistence. So this is a high var theta, this is a low var theta impulse response. Okay? So this is trying to say the point. It's like for economists to understand the property of the model, looking at this hybrid belief is going to be helpful. But for the agents who live in the model, for them, they don't need to understand what is a hybrid belief. They can just go to the fixed point directly. That's the point.
Why don't we remove?
Try this one.
Let's go bottom
Let me just drop this. I'm going to stick with the old. Yeah. I'm going to stick with the old technology then. Okay. Okay. So now this is equivalence result. So we have seen this solution to this incomplete information model. This is our main result is the dynamics going to be, it can be replicated by a representative agent hybrid economy with two modifications. One is adding this backloading component. Second is with additional discounting. It is as if like we recast this information friction into these two behavioral distortion, myopia and anchoring. Important thing is these two behavioral distortion going to be increasing with the general equilibrium effects, gamma, and increasing with information friction, sigma.
What do you mean by anchoring?
Anchoring means that it's going to be linked with the past aggregate action.
I don't know whether is it a representation theorem or a statement about another world.
This is a representation theorem.
So that hybrid economy is accused of the same crime that Bert is accused of this horrible language. It's a hybrid between is that you can replicate it with a decision rule that looks to you. It's a way to represent the fixed point of the world. There's no economy here.
I'm trying to say that this is a new economy. In this new economy with representative agent, the outcome going to be the same as the income information. So this is the economy in the DSG literature people like to use because this can mapping this empirical time series well. So we want to say that in the DSG literature, they try to give this component in ad hoc way, and our income information model can rationalize this modification. Okay. So bottom line is you start with income information model. You can always find this pair omega f and omega b such that the outcome going to be the same as you live in the representative agent hybrid economy.
But there's no environment that will be
certain because you start from an environment, let's say new Keynesian environment, that gives you something like this, but doesn't have the anchoring, etc. No?
And that is the opposite. And then you have an environment that yields this, that is sort of stupid, because it has fixed prices.
So it's like, say, the hybrid, the reason I call it the hybrid economy is because the original Galli-Gertler model, they say, okay, some of the firms are going to be backward looking.
I see, so they just put it
Ad hoc way, so they call it hybrid, so we call it hybrid also.
All right.
Okay.
But should the proposition be the opposite?
You know,
Take a hybrid economy or,
Uh-huh.
or a representation of each type. There is an incomplete information economy that
in 2 slides, you're gonna see that.
Oh, okay, but that's,
We're gonna have that.
so there are two different
Yeah,
theorems.
yeah.
This is one.
This is one way, have the other way coming. So this is kind of like the way to understand why you have this myopia, why omega f is less than 1. So if you think about our earlier representation, which is aggregate action with income information can be written as a sum of all this higher belief. Then now consider like the current action response to a news about the future fundamental, T plus H. In H period, you receive news about that. So what happens is the response of a current action AT going to depend on the H order belief in the future. And we see the figure that higher order belief going to be less responsive compared with the first order belief. So thinking about this path of this action going to be the same as thinking about the path of higher belief because it's less responsiveness. This gives the result that as if the news is discounted. This is why you have additional discounting because higher order belief move less than the first order belief. Now think about this anchoring, why you have this last period AT showing up in the equation. The reason is if you think about it, just first think about the common filter about forecast, the fundamental itself, CT, the first order belief. The forecast rule going to be my current forecast going to be some weighted average of about my prior about CT and this new signal about my CT. This is going to be the kind of like the common filter. So naturally, the past belief going to show up as a state variable. In our equilibrium, it's different than this because not only we care about this first order belief, but we also care about all this high order belief. So at the end of the day, what happens is the relevant state variable is not going to be this, but actually AT minus 1. And also, how strong is it, how large is the common filter, this common gain is going to depend on the degree of complementarity or degree of general equivalent effects. Okay, so it's more complicated than this, but has a similar flavor. How many minutes I have? 10 minutes, okay.
Yeah, 10 minutes.
Let me skip the literature, but I want to mention one sentence. So in the information literature, we have this observation that a higher order belief have this inertia property. So it kind of give you this sluggish response. And in the DSGE literature, people do is for each of the component Euler equation, you can see this curve, we're going to modify them each by different modification. And here we're going to deliver a unified macro foundation to all this modification. And recently there's a growing literature on boundary rationality. Like for example, Sharika had this New Keynesian behavior New Keynesian model, and Farhi-Verning has level K thinking. All they deliver is they have additional discounting, but they're going to restrict that there's no backward looking. But if you look at data, this backward looking is a strong empirical regularity, and here we can deliver both, and we're remaining this rational expectation framework. So now I go to the other direction. What I just told you about this equivalence result is, suppose I start with income information model, I can find a hybrid economy. Suppose I go the other way. Suppose I start with a hybrid economy. Can I find the income information model to rationalize this? The answer is not necessarily. Only a class of this hybrid economy can be rationalized by income information model. The hybrid economy is a representative agent model with these two components, this hybrid economy, backloading component and additional discounting.
So basically, this is something like the Keynesians put the whole responses.
Just putting a line,
Yeah.
putting a line,
Yeah.
and then you compute the rational expectations within the information.
So,
So what I'm trying to figure
Yeah.
out is when you mention
mhm,
in that papers of Mario's,
yeah.
that he advocates looking at higher order units where h is equal to 1,
Mhm.
right?
Not h equal to 1, but infinite hybrid belief.
Infinite? But that's rational expectations, right?
Yeah.
Whenever I see higher order belief,
Mhm.
can I understand it's rational expectations with incomplete information? That's,
Not necessarily. I would say the following. So higher order belief is a result, by itself, you can think about as a purely statistical object. It's just when you have asymmetric information, you can forecast others' forecast. You can always do that, whether it can be independent of equilibrium. You can always compute that object. I give you your information, I give my information, I can always forecast your forecast. I can always forecast your forecast by my forecast, and so on and so forth. I can always do that. That's independent of equilibrium. It just happened in a way that equilibrium action turns out to be a function of a particular weighted average of this higher belief, and typically depends on infinite higher belief. Should I move on? Okay. So suppose I start with a hybrid economy. I want to see if I can find income information economy to rationalize that. So think about this is the space of omega B and omega F. So what happens is only like one particular class of omega B, omega F pair that falling on this red line can be rationalized by the income information model. So this is a very simple testable implication of the model. So if you look at the model from New Keynesian literature, you can see whether they are omega B, omega F falling on this line or not. That's a simple test we can do. So I'm going to skip this, and I'm going to the application to actually show you the number to see whether they're falling or not. So this is the slide I showed you earlier about this New Keynesian Visschers with income information model. So what I'm going to assume is the following. This is a standard firm's pricing decision. The modification we're going to do is that we're going to assume that all these firms, they do not see the fundamental real marginal cost perfectly. All of them are going to see a noisy version of the real marginal cost. They see a noisy version with ZOIT noise. It's the same as what we assumed earlier. And you can derive that the aggregate inflation dynamics going to look like the following, which depend on the entire path of the average forecast about the future real marginal cost and the future inflation series. And this outcome can be derived from the beauty context model. And you can see that how this var phi, beta, and gamma linked with underlying parameters. Okay, so this is the model. Based on our equivalence result, the outcome of this model with income information can be replicated by this particular hybrid economy. And this is the same model as in the Galli-Gertler model. And we can see whether their estimate of this omega B, omega F falling on this red line we showed earlier. And this is how it looks like. So the red line is our theory. If you want to be replicated by the information model, omega B and omega F pair has to fall in on this line. And these three circles are the baseline estimate from Galli and Gertler paper. You can see that they are pretty close to our theory prediction. Okay.
So your example, these marginal costs that they are seeing is, for example, the wage at which they hire workers. So should I think of your case as I pay an perfect wage, but you are still clearing markets?
So the answer is the following. Here, we're going to assume that each individual firm is going to treat this real marginal cost as exogenous process. Whether it's a real wage or wage plus a rental rate and blah, 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 it doesn't matter. You have your ideal underlying model. You have a process for the real marginal cost. In the equilibrium, that's going to be some exogenous process for individual firm. My standard is going to be the firm underlying what is the statistical process for those real marginal costs. They take that as given and go to the model. Okay. So this test only tells you that the original Keynesian curve with hybrid economy can be replicated by our income inflation economy. But it doesn't tell that the required information friction is reasonable or not. So our next job is to see whether this required information friction is reasonable or not. The way we do it is the following. We're going to use the inflation expectation survey data. So in the survey operation forecaster, they ask people, what is your forecast about next period inflation and 1 year ahead inflation and so on and so forth. They're going to make some forecast error. And particularly, Colby and Garnishenko run the following regression, which is on the left-hand side is the forecast error. On the right-hand side is the past forecast correction. Suppose you live in a world with perfect information. This forecast error should be independent of past inflation-related stuff. This K should be 0. If K is a positive, then it's indicating that you have a correlated forecast error. That's a sign you have information friction. What happens is this number is a positive and statistically significant in the survey data. What we're going to do is we're going to run our model generated data and run the same regression as indirect inference exercise. We're going to match the same K as in the survey data. And this helps us to pin down what is the size of information friction. And it turns out that to match the survey data, the required information friction tells us that the corresponding omega B, omega F should fall in this range, and which is pretty close to required information friction to generate Gallagher evidence on omega B and omega F. In this sense, we say that we jointly match the survey data and the time series data on this Keynesian curve estimation.
Here you're just matching the aggregated survey data, right?
The average, yes, average.
Individual forecasters don't look like the individual forecasters in your model, just on the average they do.
So there's two statements. One is what we matched is the average forecast in the forecast data. We do not look at each individual forecaster in the survey.
Because your individual forecasters are behaving rationally, whereas in the survey they exhibit more bias.
So there's a question of whether you take the individual participant in the survey, how their behavior compared with the model. That's a different question. So there are different papers trying to deal with, but that's not what we're trying to do here. We can try to look at that, but it's beyond this exercise of this paper.
Those kind of your motivations trying to match microevidence, right?
If we want to do that, we can go in one step further to do that. We haven't done that. Yeah. Okay, so this is the last figure. We're trying to show that, okay, given that we match this survey evidence, this is how the impulse response of inflation look like. With complete information, it has no hump-shape response. And with information friction, it looks like this. And this peak happens after 4 quarters. So they have a pretty strong hump-shape response. Okay, to conclude, this paper will try to provide the theory of myopia and anchoring. We recast this hydro belief as a behavioral distortions. And we try to say this provide the micro foundation for this original ad hoc DSGE add-ons. And this trying to connect this micro and the macro evidence, and we show that could be promising in a quantitative way. That's it.
Thanks.